In this lecture, we are going to be learning how to use recursion to calculate factorials of numbers. Factorial is a popular mathematical computations that is used to calculate what we call a factorial of a number. And the factorial of a non-negative integer written n with this symbol exclamation mark, usually called exclamation mark, but in this case we call it factorial symbol, is the product of the number n. So we have n of n multiplied by n minus 1 multiplied by product of n minus 2, a product of continuously up to 1. So with 1 factorial equal to 1 and 0 factorial equals to defined as 1. For example, now when we have, say we have 5 factorial, then the same thing is equivalent to saying 5 times 4 times 3 times 2 times 1. So any number we multiply continuously until when we reach 1. And also the factorial of 5 will result to 120. So a recursive definition of this factorial function is arrived at when we look at the following relationship. When we look at, say, n factorial, we have it is equivalent to n factorial is basically equivalent to n product of n minus 1. So n multiplied by n minus 1, as we can see in this particular example. When we have 5 factorial, it is the same thing as saying 5 times 4 times 3 times 2 times 1. And when you look at it, 4 times 3 times 2 times 1 is just the equivalent of 4 factorial. So we can confidently say 5 factorial is the same thing as saying 5 times 4 factorial. And then equipped with this knowledge, now we can be able to calculate the factorial of any number using recursion. So let's say we have we are using recursion to compute the factorial of 5. Now we can have when we launch 5 factorial, we know that it will reduce to 5 times 4 factorial. Now 4 factorial will also reduce to 4 times 3 factorial, and we know that also 3 will reduce to 3 times 2 factorial, and 2 factorial will reduce to 2 times 1 factorial, and we know that the factorial of 1 is simply 1. So as we can see now, and then this will continuously. So now we know the factorial of 1 as 1. So we can say that we can now we have found the factorial of 2 times 1 because we have found the factorial of 1, which is 1. So we can say that factorial of 2 is simply 2 times 1, which is 2. And factorial of 3 is same thing as saying 3 times 2 factorial, which is 3 times 2, which is 6. So continuously up to we have 5 factorial, which is 120, as we can see in this particular diagram. So we can see that 1 factorial is our base case, which is the simplest, which is the terminating condition, and then we can now use the relationship that we have of 5 of any number expressed as n factorial is equivalent to n multiplied by n minus 1 factorial as a recursive step, as a recursive function. Okay, so to illustrate this, I'm going to be creating a program that will find the factorial of 10 numbers. Given it will simply calculate the factorial of 1 from 1 to 10. So now let's go to our text editor and then try to see how we'll be able to create such a program. So I've already created a file and I've named it recursivefactorial.c, and I've already input some things within the particular file. So as we can see, there's nothing new here. We are already familiar with already what is here. So line number 8, I've already defined a new function, the factorial function, the function that we are going to be using up to compute the factorial for us. And the only thing that is new here is the data type, unsigned long int. Now the essence of using this new data type is for it to be able to accommodate the range of values that factorials is going to generate, because factorials usually generate a large numbers. So it is also good for us to make sure that the data type that we declare the variable that will hold those factorial is also big enough to accommodate the numbers that is going to be generated. All right, so now I'm going to start coding. So I will come here, I will make use of my for loop to iterate through 10 numbers. So I can say for int x, for int x equals to 1, initialize a variable x of integer data type to 1, since we want to iterate from 1 to 10, and x should be less than or equals to 10, which is the condition, and then x should be incremented by just a single step. Okay, sorry, just be incremented by a single step. And now we have this. So now for each step we are going to invoke this particular function that we are going to define later, that will be responsible for generating for computing the factorial for us. So I'm going to say print, make use of print to each time make a function call and print the factorial for us. So we can see the factorial of the number of this number is this. Okay, so but we have defined in this particular function, we say the return type is unsigned long int. So when we invoke the function, we expect it to return a number that is of this data type. So for me, I have to make use of a conversion specifier that is for this particular data type, and this is the conversion specifier for this particular unsigned long int LLU. Okay, so I have this. The factorial of x is this. All right, so and then I have this. Now I'm going to write I'm just going to factor x, then I'm going to now invoke the function factorial, and then I'm going to pass x as my argument. All right, that's my argument. So now let me just n4 comment this one and 4, right? So now I can go and define my function that will be responsible for computing this particular factorial. So I can say I've already defined the function in the function prototype. So the function declaration, the function definition header has to match what is in the function prototype. So I have unsigned long int factorial. So I have and I am passing this as my parameter. I'm creating a parameter int number, and then I have my function proper, function body. All right, so now the first thing that we are going to do, we are going to check if the number is in the base case. As we have seen previously, our base case is going to be 1. So if the number is in the base case, so we simply return, our base case is when the number is 1 or 0, and we are going to simply return 1 as the factorial. So I'm going to make use of if selection statement, if single selection statement, to check if number that has been passed is if number is less than or equals to 1. We are aware of good faith that since we know that our program is going to generate numbers starting from 1 to 10, and we know that the factorial of 0 and 1 is going to be 1. And in this case, one number can never even have the value of 0. It's going to have a value starting from 1 to 10. So we say I can see it's sorry, this is not greater than, it's less than or equals to, or I can say even confidently, since I know that my number x is going to have number starting from 1, it won't have 0 as a value. So I can say if number equals to 1, if number is equivalent to 1. But since we know that both 0 and 1 have the value of 1 as its factorial, so let's just use the general case. So if number is less than or equals to 1, then we are going to return we're going to return 1. We're going to return 1, which this is our base case. It's the most simplest case, that and the termination case. the termination case, or let me call it base case. We know that all the recursion will eventually converge into this particular number. We simplify to when number is 1. All right. So now next, else, then we launch our recursive call. Then we say else. We now launch our recursive calls by saying, since we have seen that in the explanation, then it's going to be number. We are going to return this. It's going to be number multiplied by factorial of so this is where we have the recursion. We are this function is calling itself again. So as we can see, this particular factorial function is calling itself. So it's going to be number, as we have seen previously in the explanation, minus 1. We know that the factorial of 5 is the same thing as saying 5 times 4 factorial. So this is the same thing. So we are this from particular function factorial is calling itself again, and we have already explained it with the aid of a diagram how this function call is going to look like. So and then let me paste statement terminator here. So now this at line number 30, it will launch a fresh function call on itself. It will go back to the function call, and then now it will check. Let's say we are for the first time 1 x, when x is 1, it will simply return 1. Now for the second time, when x is 2, then it will check if its number less than or equals to 1, which is not true in this case. Now it will proceed to line number 28, which is the else part, and then it's going to return number times factorial of number minus 1, which is the same thing as saying 2 times factorial of 2 minus 1, which is 1. So it's going to be factorial and then factorial of 1, which it will go back again, and then it will see that number is 1. So it's going to come back, and we have 2 times 1, which is 2, and so continuously like that. This is the way it's going to work. We have already explained that with that particular diagram. So this is how this particular function recursion is going to work. So let me put a comment here, and else, and else, and we have here and if. All right, so and then and function factorial, so function factorial. So this is how it's going. So let me save it, and then I'm going to run it. If there's any error, we'll come over and get the error. All right, so let's have, after this, let's print a new line so that the printout will not get packed in one place. So I have this. So let's go to the terminal and compile this program and see how it's going to work. So I'm going to cd let me include this cd documents programming. I have this cdc lectures. So clear, and then we have my GCC compiler, recursive factorial.c, and then I'll put it as recursive, and then we add the .c extension. So as we can see, our program has compiled successfully. That means we don't have any error. So now let's run it and see how it's going. The output is going to be whether we are going to get factorials of numbers from 1 to 10. All right, sorry. I'm going to run this within this directory. I want to run recursive.c. So factorial of 1 is 1. The factorial of 2 is 2. The factorial of 3 is 6. The factorial of 4 is 24. So as we can see, this program is working perfectly. And this is just an example of how a recursive function works. We have a function calling itself, and we have explained and we have given an example of a recursion of a recursive call using this factorials, computation of factorials. Now, in the next lecture, we are going to see how we can compute these factorials of numbers in an iterative way, which is the opposite of recursion in a non-recursive way. Thank you for taking your time to watch this video.